Hi, this is Leetcode question, data stream as disjoint intervals. Given a data stream input of non-negative integers a1, a2 up to an, summarize the numbers seen so far as a list of disjoint intervals. Implement the summary ranges class. Summary ranges constructor initialize the object with an empty stream. Add num adds the integer value to the stream, and getIntervals function return a summary of the integers in the stream currently as a list of disjoint interval start I, end I. The answer should be sorted by start I. First of all, suppose we have numbers 1, 2, 3, 4, 5, 6, 7, 8, and if we have this interval 1 to 3, so this is the start and this is the end. This means all the number from 1 to 3 were added, so 1, 2, 3 were added. Now if we have the interval 5, 6, this means that all the numbers from 5 up to 6 were added. This is 5, this is 6. Now if we have interval 8, 8, this means all the number from 8 up to 8 were added, and 8 up to 8 is the one number, which is 8. Now let's take this example. First call is add number 1, so 1 is added. This is 1. Now the next query is getInterval, so the only number added is 1, so in this case we return this interval 1, 1, and that means all the number from 1 up to 1 are added, which is only one number. The next function is add number 3, so we add 3. Now getIntervals will return all the intervals, so the number added are 1 and 3, and in this case we return interval 1 to 1 and another interval 3 to 3. Notice that we cannot return 1 to 3 because this means that all numbers from 1 to 3 are added, which are 1 and 2 and 3, which is not correct because 2 is not added yet, so we return only 1, 1 and 3, 3. The next call is add number 7, so 7 is added. GetInterval query will return 3 sets, 1, 1, 3, 3, and 7, 7. Then next we have add number 2, so here we have 2. Now notice these 3 numbers forms one segment. We can merge all of these number into one set, which is 1 to 3, which means all the numbers from 1 up to 3 are covered, 1, 2 and 3. So in this case, for this interval, we return 1 to 3. we don't return 1 1 2 2 3 3 because we can merge all of them into one set, and we have 7 7. The next query is add number 6. So we add 6, and notice 6 and 7 are neighbors. We can merge them into one segment, which is 6 to 7. And so for the next get interval, we return 1 to 3, which is the first interval, and 6 to 7, which is the second interval. And notice the intervals are sorted based on the start values. Now, how can we solve this question? We need to use the set data structure in C++. We use set of pairs. Every pair will represent an interval. The first value is start, and the next second value is end. And in C++, by default, set will sort the pairs based on the start value. First of all, we need to get next for our value, and we will use the upper bound function, which is a binary search, and the time complexity for this one is log big O of log n, or the size of the set. So we use this function, and this function will return an iterator or pointer to the next element. Now assume we have a set of these intervals 2 to 3 and 4 4 6 8 and we call the upper bound function when we add a value, for example 1. So the upper bound function will return the pointer to the first value greater than 1. The first value greater than 1 here is 2, so it will return a pointer to this pair. Now if we want to add the value 2, upper bound return the first pair that has start value greater than 2. If this one is equal to 2, so this one is the first pair which has value greater than 2, so it will return a pointer to this pair, and this will be our next value. Now if we search for value 5, the first iterator or the first pair that is greater than 5 is this one, so this will be the upper bound return value. If we are looking for 6, this value is 6, so we return a pointer to the end of the set. And so after we call upper bound, we get the iterator next to our value. Now if the next is not equal the beginning, if it's not here, we handle it in different way than if it's at the beginning. Now if it's not the beginning of the set, like here or this or this, we need to get the previous pair. So the previous for this one is this, and the previous for this pointer is this. The previous for this one is this. So now we have the previous and we have the next. We need to check the value. If the value we want to add is greater than previous first and value is less than previous second, in this case this means the value is already added. We don't need to do anything, so we return. So for example, assume we are adding the value 4. Now the upper bound will return the first iterator next to 4, which is this one. So this will be next, and the previous will be this one. So this is the previous. Now we need to check if this 4 is greater than or equal to start and less than or equal to the end, and this means that it's already added, and indeed 4 is already added. So we need to return. We don't need to add the value 4 again. Now this case, if the value is greater than previous second plus 1, this means that if imagine that here we have 7 instead of 8. Now we want to add the value 5. So 5, the next will be this, and the previous will be this one. Now this, check if the value is greater than previous second plus 1. So this previous second, which is 4, plus 1 equal 5, and this is the value that we want to add. So we need to add 5, and if it's not greater than previous second plus 1, it means that we can merge these two segments, which we will handle it here. But if it's greater than 1, for example, if we want to add 6, so 6, again the upper bound or the next value will be here, the previous will be here. Previous second is 4, 4 plus 1 is 5, so 6 is greater than previous second plus 1, and that means we cannot do the merge with the previous interval. Now we need to handle this condition. First of all, if next is not the end of the set, we will handle it in this if statement. This means if the pointer is not here, the next one, we will handle it in a special case. In this else, we just add or insert the value, and that's, imagine we are adding 10 here. 10, the previous value is 8, 8 plus 1 is 9, so 10 is greater than 9, and the pointer is the end. So what we need to do is just to insert this interval into our set, and this is what we do here. If not the end, if it's not the end, we need to check here if the value equal next first minus 1. For example, if we are adding 6, so we set 6, the next value will be here and the previous will be here. 4 plus 1 is 5, 6 is greater than, so we come into this condition. But 6 plus 1 equals 7, and this equal the next value first, which is here, or you can say 6 equals 7 minus 1, and that means if we have this interval, this means 7 and 8 were already added, and we want to add 6, and that means because 6 plus 1 equal 7, which is the first of the next interval, we can merge this into one interval. So what we will do is we insert a new interval, which is value and next second, which is this value we added 6 and 8. So we have already 7, 8, and we want to add 6. We merge them together into 6 to 8, and this is what we are doing here. Then we remove the 6, 8 or 7, 8 interval because it's already covered in from 6 to 8, so we replace it by 6 to 8. Now if it's not equal, next, like if we add 5, we said 5 does not equal 5 plus 1 is not 7, so we just add the value new interval. Now here we said if the value is greater than previous second plus 1, as we mentioned here, we add 6, and 6 we cannot merge 6 to 4 and 4. This is 4 and 4, so come here. But if we, for example, we want to add 5 equal 4, which is the this second plus 1, then that means we need to merge this into this one, and this is what we are doing here. First we need to check if next is not equal to the end of the set. If it's not equal to the end of the set, we need to check these conditions. If value plus 1 equal next first, and that means assume we have but also remember this is as an example, so 2, 3, 4, 4, this is not possible because 2, 3 and 4 you can merge them, so the correct one is 2 and 4, but we showed these as just an example. Now let's take another example. Let's say we have vector of intervals 3, 4 and 6 and 8. Now if we want to add 5 equal 4 plus 1, and also 5 equals 6 minus 1, so we need to add 5 here, and this means we need to merge this and this, because 3 and 4, this is 3 and 4, and 6 and 8, this is 6 and 8, and we need to add 5, so all of these we need to merge them into one interval, and this is what we do here. So value equal previous plus 1, and value plus 1 equal next first, so we need to merge the set, and we replace the previous and next with the new set, the merge big one. If not equal next first, it's only previous second plus 1, that means we need to merge it with the previous set. Now if next is not equal to the end, or if it's equal to the end, here we just need to merge it with the previous one and erase the previous. Else, we said this else statement at the beginning, we said we need to check if next equal to the begin or not. If it's not in the begin, we do it here. If it's in the begin, we do it here. For example, if we are adding the value 2, the next will point to the begin of the set. So we need to handle every condition. If next equal end, and that means, imagine if we have this set 3, 4 only, and we want to add 2, so the next is this one, and or if you want to add 5 is pointing to the end, and this is what we are checking here. In this case, the next equal the end of the set, and we just insert the new interval 5, 5. Else it's not the end. So for example, if we are adding 2, the next will be at this pointer. Again, we need to check if the value we are added equal to next first minus 1 equal value, so that we need to know if we want to merge. So if we add 2, 3, 4 are neighbors, so in this case we need to replace this set with a new one, 2, 4. If not, for example, if we are adding 1, that means we just want to add this interval 1, 1, and this is what we are doing here.